our revered functional directors, Director Technical Operations, Dr. Anindya Sinha, and Director Technical Projects and Planning, Shri S.S. Sinha sir, to this auditorium. I also welcome the authors. There are 2 authors who would be presenting physically in the keynote session. And there are 2 authors be taking their names who would be presenting in the virtual platform. So we have 4 important authors for this keynote session, which is a prelude to the technical sessions that would follow now onwards. There would be 1 session before lunch, and then 2 more after lunch for this day, for today. And the rest of the sessions are scheduled for tomorrow. So in the keynote session, we have, it's about the future of coal. Like I already deliberated in the inaugural session, that right now coal is very delicately poised at a crossroad. Mandate is against burning of fossil fuels. India already has its NDC commitments in COP21, Paris Climate Summit, that need to be complied with by 2030. On the other hand, there is a challenge from the renewables because we need to increase our renewable trajectories. So this is a transition, climate transition at this moment, where we need to deliberate and we need to find real coal. Right now is occupying the center stage for India's energy matrix. around 55% of India's energy is still from coal, 62 from thermal power and 55 from coal. So coal occupies center stage. Coal is here to stay, and we have coal reserves of around 156 billion tonnes as on April 2019 figures. So we still are the 3rd largest. We have the reserves of coal. So various ways of exploring and various renewable trajectories. So we need ways forward for coal. So this is what future of coal in India is basically going to be deliberated. This is the topic, and there are various other topics. So introducing the topics and introducing the speakers for the keynote session. The first session would be on future of coal in India. This would be presented, the session for this is Dr. Anindya Sinha, Director Technical Operations, Northern Coalfields Limited. And the next paper, this would be presented by Sir physically in this session. And the other paper that is going to be physically presented is development of a model to find relation between the stripping ratio and strike length of a coal mine block area. This is another important paper. The paper was basically, the paper presenter is Shri P.M. Prasad, Director of Central Coalfields Limited, and Shri Manish Kumar, Chief Manager Mining from CCL. He was with us previously, he was with Nigahi project, but right now he's been transferred to CCL. And he, on behalf of CMD CCL, would be the paper presenter for this, for the 3rd paper. And the other 2 papers, Geotech properties of cemented coal fly ash backfill. This is going to be presented by Erol Yilmaz from Turkey. This is going to be done on the virtual platform. And the 4th paper on blast-free and eco-friendly coal winning by using surface miner. This is also going to be presented virtually by Shri Baban Singh, who is the Director Technical Projects and Planning, Mahanadi Coalfields Limited. So now, after having gone through the papers and the paper presenters, I would want to invite upon the dais, sir, please, I humbly request our Director Technical Projects and Planning, who is the chairman of this session, Director Technical Projects and Planning, NCL, Shri S.S. Sinha sir. Please clap. I think all of us have been refreshed with tea and snacks, so we can clap harder. Can we not? Because we are lesser people here than the inaugural session. Welcome, sir, to the dais. So, Shri S.S. Sinha, sir, he would be the chairman of this session. And the co-chairman and the rapporteur would be Shri N.B. Singh, sir, who's ex-general manager excavation, Northern Coalfields Limited. He's with us, so I would welcome and request Shri N.B. Singh sir to please take the dais as the co-chairman and the rapporteur of this session. Thank you, sir. Now I would want to invite the physical authors on stage. The first author, Dr. Anindya Sinha, Director Technical Operations, Northern Coalfields Limited. Sir, I humbly request you to please take the dais for the presentation of your paper. Can we clap a little bit more? And the other physical presenter for this session, I would want to invite on the dais Shri Manish Kumar, Chief Manager Mining from Central Coalfields Limited, who is here to present the paper on behalf of CMD CCL, Chairman cum Managing Director, Central Coalfields Limited, Shri PM Prasad sir. So welcome sir, Shri Manish Kumar, Chief Manager Mining. Please take your seat. Thank you sirs. Thank you. So now I would hand over the session, and before handing over the session, I would want to announce that we have the other two presenters, Erol Yilmaz and Shri Baban Singh. Erol Yilmaz from Turkey and Shri Baban Singh, Director Technical Projects and Planning from Mahanadi Coalfields Limited. They are also with us here virtually. They have joined us. They are connected virtually. This session, keynote session of ICOMS 2020. A very good afternoon, sir, to both of you, and welcome to you to the ICOMS 2020 platform. So now, before I hand over the session to the chairman, I wish to request him that Erol Yilmaz would be requested to present the first paper, followed by Shri Baban Singh for the presentation of the second paper, and then, sir, we can take up the physical papers. So this is over to the chairman, Shri S.S. Sinha, sir, Director Technical Projects and Planning, Northern Coalfields Limited. Over to you, sir. Thank you, sir.
So welcome our delegates and dignitaries. I now invite Professor Erol Yilmaz from Turkey. Am I audible to you, sir? I'm sorry, I can't hear your voice.
So, are you able to see my screen?
Oh, you can go ahead, sir. We can hear you.
Okay, thank you. First of all, I would like to thank you so much, Professor Piyush Rai, to invite me such a nice presentation. I'm so happy to join and share my ideas and perspectives. So today I'm going to explain the subject which is very important for Turkish coal mining. My presentation name is Assessment of Geotech Coal Fly Ash Backfill. We prepared this presentation with my colleagues, Ibrahim Çavuşoğlu, who is Associate Professor, and myself and Ali Osman Yilmaz, another co-authors. So my presentation will be outline introduction, underground coal mining. I will explain a case study in Çayırhan, which is the capital of Turkey, Ankara. I will talk about materials and methods, fly ash, cement, mixing water, preparation of backfill samples. After the materials and methods section, I will explain the results by focus on water to cement ratio, setting time, strength properties, porosity, and pore structure. Finally, I will make some notice and recommendation. So first of all, I would like to explain what is the backfill cemented coal fly ash. Here we can abbreviate it SCCB. So there are 4 basic ingredients to prepare this backfill material. First of all, we have an admixture. This admixture can be the plasticizer or accelerator. The second one is coal fly ash, which coming from the mining side. It's a kind of byproduct. We have to use it in a backfill as an aggregate material, and we also need some binding material as Portland cement type 1. Finally, the water. You can see here the ratio. So we prepare the 70 percentage by weight fly ash, and 20 to 25 percent by weight binder, and little quantity of admixture, and mixing with water, we consist of backfill material. So here I would like to explain the project motivation a little bit. Cemented coal fly ash backfill, actually it's designed to have certain values. Why? Because we have to make sure that there is no subsidence due to the or collapse due to the coal mining activities in underground mine. So coal reserve, coal materials, we have to replace it some backfill materials. So over there, based on the coal production speed and geometry of underground voids, we have to get some target strength values. At that time, it's really important the quality of the backfill. So we must make sure that we have to insert the underground enough strong material. So at that time we have to look for the physical, chemical, thermal, hydraulic, mechanical mechanism. So greatly affects the quality of backfill. So we know that the use of coal mining waste like fly ash in construction materials are really poor. So we have to add some Portland cement to get enough cohesion. So that's why in the literature we cannot see so much work on it, and so we decided to do some research on these topics, and we find some interesting result that today we will share with you. Here the mine site that we work on it. Here it's Ankara, capital of Turkey, and you can see on the screen dash. So the company are trying to find some useful options to evaluate those useless material. Actually, we can call it the raw material, but we have to find a way to evaluate them. So generally, they put this waste near the coal mines due to the high cost, shipping cost. So, but we know that also stacking those issues near the mine site can create also environmental handicaps due to the sulfide content, and which will create some acid mine drainage, which will contaminate the environment. So you can see here and you can see also there is a dam, huge dam to accumulate water with fly ash. So also we know that recently there have been some other sectors to use those high voluminous ashes. We can use it road construction. We can use it another application like brick construction. As you can see here the some of the photos you can saw it, but our intention is to use the fly ash as a ground support element in a Turkish lignite coal mine. So when we extract some coals, we can replace it with already taking some coal reserves, but it's not useful for the sector. We can remove them back. So to reduce the cement related cost, we use 25%, 25 to 5%, and 80% of fly ash. And also we got some different curing times, 2, 7, 28, and 90 days. What was our intention is to study the effect of fly ash content of slump consistency and the inertial compressive strength, because test strength like setting time and consistency, Mercury, Intrusion, Fosmeter. Here also the mine, underground coal mine, Çayıran in Turkey. You can see the map, and you can see also the satellite pictures. It's a kind OPENCAST coal mine producing 5.5 million tons per year, and approximately 350 million of coal are already reserved over there. So our mine is running efficiently and contributing to Turkish economy by extracting coals to use the thermal plants to produce. Here also the figures how we implement of cemented coal fly ash backfill. You can see the section, and cement and fly ash prepare on the surface. There is a pipeline. We transfer them into underground. At the underground there is a backfill mixing station. Over there, just we add the water to mix truly the cement and fly ash, and by following again the pipeline, plastic HDPE pipeline, and we put them behind the coal, which already taken coal and broken. You can see here the picture, operator. There is an application, and those area is backfill area, and we know that some strata is subsidence, and we fill it and get some strong material which will not allow any subsidence after application. Also here the underground coal production. Actually there is two way for application. The first one, backfill without accelerator, and second one, backfill with accelerator chemical. If you use the chemical admixture, then your backfill material will get stronger at a shorter time, because due to the fact we need to increase the speed of production, we have to also create a very solid material. As you can see, the strength criterion, UCS should be the 5 megapascal, almost 2 days of curing time. As you can see here, the B backfill with accelerating, you can see you can increase the coal production, but when without accelerating, which means backfill not mature, will not give you the will not allow you to produce a high quantity of coal. So let me explain you the materials that I use during our work. There's here the particle size distribution curves of fly ash and cement. Here the x-axis, you can see particle size as a micron. And the y-axis value, you can see the cumulative volume, 2.100%, and oversee that coal fly ash material is coarser than cement and ranged 1 millimeter to 1000 millimeter, as you can see, and cement is finer than fly ash. There is also some coefficient of curvature uniformity values, as you can see on small table, and the specific gravity of fly ash 2.15, and while the specific gravity of cement 3.1. Here also the chemistry of fly ash and cement. There are actually two classification of fly ash. One is type F. Type F, if the silicium dioxide, aluminum and ferrous value of coal fly ash greater than 70%, it's called the type V fly ash. So when you calculate the value of fly ash, you can see that our material belong to the type F. Type F compared to type C produce a lower UCS value, strength value. And also, I want to explain how we prepare the samples and which way we follow for design of backfill materials. So we use 20 liters capacity mixer. So we mix it the coal fly ash, cement, and admixture as well as mixture for 6 minutes. After mixing, we place them into the plastic cubic molds, 5 centimeter cubic samples. Then let them to cure in a room which has 90% humidity and 22% temperature, which reflects the underground conditions. So here in this study, we got the 4 different curing times. The reason of after those waiting times belongs to the a schedule time which coal will create some subsidence in, especially for example 3 months later. There's no importance to get it because you will complete all the extraction procedure within the 3 months. Here also the some values, water to cement ratio. We also keep the constant slump value as 20 centimeter. We use different laboratory testing. Here, number 1, we use the slump Abraham cone, 30 centimeter height, and the second, automatic WCAT instrument for initial and final setting of backfill material. Third one is a mechanical press with 300 Newton load capacity. Also, we used here 2,400 Newton per second for as a displacement speed. And last, we also use Micromeritics Auto Pro Mercury intrusion Fosmeter to measure the pore structure of backfill. Here the results. You can see we use 3 different fly ash content, one 80 and the others 75. So you can see also y-axis values water to cement ratio. You can see when the water to cement ratio decrease as the fly ash content in the mixture decrease, you can see which means the cement content increase. So when you increase the cement, at that time water to cement ratio is getting down, is a little bit. You can see a green bar. Here also the effect of fly ash on setting time of backfill. Again, when you increase the fly ash content in the mixture, you will see the strength setting times also increase. Prolongation of setting times are affecting two reasons. First one, lower cement content, and second one, higher water to cement ratio. And here another results of effect of fly ash on strength gain of backfill. So when we increase the cement, automatically you will see the high strength value. It's because of hydration products. Particles in the backfill will connect each other and will close some gaps, which will reduce the pores. Later on, you will create a high density material, so which will give you the high UCS value. Here also the proof of what I said in the previous slide. Effect of fly ash on porosity on the backfill. Of course, when you increase the cement content, which means 20 to 25%, you will see the total porosity significantly decrease 28%, which will create a higher value. And I'm coming to the end of my presentation. Last 3 to 4 slides remain. And here also the Mercury Anthrosion Fosmeter results. Here the cumulative MIP results. You can see that with the increase of the cement in the backfill, pore throat openings decrease due to the cementation effects. Blue line, you will see the porosity is getting down, and also the pore axis diameter shift the finer zone, like approaching the origin. Also here the incremental Mercury intrusion parameter.
I'd like to come in, Mr. Yilmaz. We'll have to rush up a bit. We are short of time.
Yes, now I am finishing. Thank you. I am finishing. And here also, as we can see, the water to cement ratio reduce as the fly ash content drops. Setting time increase with the increase of the amount of fly ash added to cemented. Highest strength for backfill formulated 25 fly ash to 25% Portland cement. Here, thank you so much to Gümüşhane University, where my colleagues works there, associate professor. And also I would like to thank my another co-authors, Ali Osman Yilmaz from the Karadeniz Technical University, and myself, and we did a good collaboration with 3 university. And thank you for listening our presentation.
Thank you, Professor Yilmaz. It was an excellent paper. We thank you for your presentation. Any questions, please, from the audience? Any questions from the audience?
Can you hear me? Hello.
Yes, I am hearing.
In the slide number 3, you are showing that it is intended for in situ filling. Is it so? In the third slide of your presentation. Hello.
Third.
Hello, in the third slide,
This one?
is this admixture what you are proposing is intended for in situ filling in the mine for support? Hello.
Actually, yes, but it's really hard to understand at that time. Perhaps the moderator can help us, or you can write it down and I can reply later.
Okay, okay. Because if it is in situ in a working mine, then the while setting it, the blasting has to be taken care of. Otherwise, the blast
Yes,
on during coal production, and if the mine is producing, then the filling area is likely to get disturbed due to blasting waves.
yes, thank you.
So thank you both. We come to an end of this presentation. It was an excellent presentation and very relevant for our times, very relevant for our times. Thank you, Professor.
It's my pleasure. Thank you.
Now, could we ask Bhavan Singh Saab, Director Technical, Mahanadi, to come and present his paper?
Okay, it is started. No? वीडियो चालू करने के लिए स्क्रीन छोटा स्क्रीन स्टार्ट करें. Good afternoon, everybody. This is our opportunity given by ICOMS to present the paper, and this paper is blast free and eco-friendly coal winning using surface miner. This paper is very significant today in the today's scenario, and there are authors, they have assisted much. Just we will deal introduction and way forwards and last conclusion. This surface miner, it was firstly brought in use in 1970, and then by the Ambuja Cement, it was introduced in 1996, and MCL was the first company in Coal India Limited. It used a surface miner, deployed surface miner in 1999, and thereafter we are progressively going on increasing the surface miners, and today we are producing almost 98% coal by these surface miners. MCL experience in this regard is very significant, since this MCL was bifurcated in 1992, and as we know that coal is formed under a drift theory where high ash and low GCV coal is found. In case of conventional mining operation, we do drilling, blasting with crushing, and in case of this surface miner use, it is all eliminated. Drilling, blasting, all. It leads to poor quality coal. It leads in deterioration of quality, and MCL started losing marketability of this coal, leading to poor revenue realization. Then it was thought that there was a revolution of this use of surface miner, and this was used in this MCL, which will be shown in the next slides. Reasons for deploying surface miner at MCL: improvement of coal quality by selective mining, easy segregation of intermittent dirt bands, and also to reduce washing and processing requirements, and need for economical and eco-friendly. I thrust here need for economical and eco-friendly continuous mining of coal, eliminating the processes of drilling, blasting, and crushing. MCL is situated near proximity of villages, so this surface miner deployment has benefited to the extent to meet the growing demand of coal in the country. Application of surface miner suitable for layered deposits such as coal and can be used for selective mining to address the quality issue in coal seams having many intermittent dirt bands, where drilling and blasting is prohibited. Areas sensitive to blasting operation in coal seams with gradient up to 1 in 4, we can use this surface miner. In the mines with soft minerals such as phosphate, gypsum, limestone, granite, salt, bauxite and lignite, etc., we are using this surface miner. A strike length of about 600 meter to 1 kilometer and width of around 300 meter are ideally suitable for deployment of surface miner. This slide is very important and very it keeps very some knowledge also. This here we have this graph depicts this green portion, yellow portion, and red portion. This green portion, it speaks soft rock with UCS, uniaxial compressive strength less than 60 MPa, where surface miner can cut economically. It is very important that this yellow color, this depicts medium hard rock with UCS up to 120 MPa. Surface miner, this strata can be cut with a special application. And red color, hard rock with UCS more than 120 MPa cannot be cut at present. So this graph and this pictorial view says much about applicability of surface miner with respect to compressive strength. Here I want to add that as far as cuttability of coal vis-a-vis selection of surface miner is concerned, we do it in two ways, which will be explained in next slides. Considering uniaxial compressive strength of coal rock, it has been explained in slide to come, and others. For even better precision, we go for considering cuttability index, which is a phenomena based upon 5 parameters, which has been explained in detail in coming slides. Here, a rating of the parameters of the rock mass cuttability classification. It has been given. In the previous slide, we could see the relation of UCS, uniaxial compressive strength. Here, there are 5 classes. It has been shown there. Assessment of cuttability by surface miner. In this case, if the cuttability index is less than 50, very easy excavation. If the cuttability index is more than less than 60 but more than 50, it is easy excavation. Similarly, with CI, which is more than 60 but less than 70, economic excavation. And similarly, it has been depicted here, it has been explained in detail. Rock mass cuttability classification, which is a CI, it is the summation of IS plus JV plus AW plus JS plus M. It is all 5 parameters. The rating has been given, and on the basis of calculation by this parameter, rock cuttability is determined, and accordingly surface miner is deployed. This is the pictorial view of surface miner. In the next slide, different models of surface miners, it has been shown. Ritzian and L&T and Pujolona, these are the companies which are making the surface miners. We are thankful to the company that they are manufacturing different kinds of surface miners with different models, with different use, with different applicability. This slide is very important in respect of MCL, where at present departmental, we have got 22 numbers of surface miners, and with the year to pass, it is increasing. It is 25, 27, and 32. With the passage of time, MCL is deploying, Coal India is deploying more number of surface miners due to its benefit. Surface miners fleet at MCL, as I explained, 93% of production, highest in any company, we are getting by this deployment of surface miners. This is just operation by surface miner. Major benefits of deployment of surface miners: growth in coal production, reduction in unit cost of coal production, selective mining, safety in operation, improved loading quality, eco-friendly billing of coal, all has been detailed in the slides to come. Growth in coal production, it has been shown that gradual increase in share of coal production from surface miner from 91.88% to 93.39% with respect to total OC OPENCAST coal production in the past years at MCL. Performance of surface miner is encouraging and it is desired. This slide is very important. It is very important. We have to concentrate and we have to note that reduction in unit cost of coal production. How much gain we are getting by the deployment of surface miner? Where is the reduction? What way there is the reduction?
Hello.
In case of
Hello.
drilling.
Hello, Singh. थोड़ा सा expedite कर दीजिएगा.
Okay, okay, sir. Reduction in unit cost, this has been explained. The present share of coal production from surface miner in CIL is 50%, and adopting surface miner in all the OPENCAST project of CIL could help generate an additional revenue of rupees 742 crore per year. Selective mining of coal, just it has been explained that reject is separated out, and the benefits thereby has been shown in next slide. This is very important. Gain in year. In case of conventional mining, if the intermittent bands is not segregated, the grade is G14, the selling price is 748, and by deployment of surface miner, grade increases G13. Though the reject is thrown to the reject dump, even then there is gain of rupees 30.26 per ton. It is very high. Safety in operation, it is much safe. There is a decrease of manpower, and an in-depth analysis as we are facing in mines of NCL also, since in such cases the performance of surface mine depends on types of dragline mining method, a strip length, seam thickness, width of dragline bench, and there is a limitation of strike length. It should be 400 minimum, and width of 200 meter is required for efficient and effective operation. Way forward to improve, to further improve revenue realize, it will take only 2 minutes. Just I am going to close it. There is a shortage of time. to further improve revenue realization and also reduce coal loss, GCV of rejects ungraded coal segregated from the surface minor cut coal shall be determined, and possibility to produce electricity from these rejects through circulate this CFBC technology shall be explored. CFBC technology is being used in some parts of India to successful electricity from washery coal rejects having ash content 55 to 60% and GCV of about 2500 kilocalorie per kg. Some studies indicate that CFBC can be used with coal having GCV of 1600 kilocalorie per kg to generate electricity. Possibility of direct loading by surface miner on trucks, dumper, or suitable conveyor shall be explored. By that way, what we feel, there are many things to be done in way forward. And lastly, just I conclude. Lastly, I conclude, it is very important. It is very important. Surface miner at MCL and Coal India Limited have increased revenue realization, reduced unit cost of coal production, and reduced the GHG from coal production in comparison with the conventional method of drilling, blasting, loading, crushing, etc. for producing minus 100 mm sized coal. There are three pillars of sustainable development, that is C. C is social, economic, and environment. This has been shown here. Coal winning by surface miner can be said to be sustainable to achieve 1 BT coal production by CIL 2023 to 2024. Surface miners will have a crucial role to play. At the last, we, on behalf of Coal India Limited, thank to the ICOMS body. They allowed us, by that way, we represented this paper, and I hope the theme of our study and presentation have fulfilled the very objective of ICOMS. We are much thankful to the ICOMS body, and
thank you, Singh Sahab. Dhanyavad.
Okay.
Dhanyavad, Singh Sahab, for an excellent presentation. I think we learned through your presentation. Or the only thing that I wanted to ask, whether we can use the machine in OB or not, or are you planning to go ahead with it or not?
It is very good question. I detailed you regarding the UCS. We can use this surface miner in OB also. It was shown in the previous slide that UCS, if it is up to 60, we are using this here, and there are many OPENCAST where the UCS is less than 60, where it can be used.
Okay, thank you, sir. Thank you very much for excellent presentation. Any question from the audience? So we'll have questions later since we are short of time. Now I request Doc to come forward and present his paper, please.
Good afternoon, gentlemen and ladies in this auditorium. Today's topic of future of coal in India is always a debatable topic. Nobody knows what future tells. We can only stress its path through some figures, through some activities, through some actions. Coal sector is now a volatile sector. With the advent and with the increased use of renewable energy, coal as a fossil fuel is an area. The various countries are gradually closing down coal mines and they are switching over to the renewable energies. But with respect to Indian perspective, we have to think and assess the future of coal, and accordingly this paper is being presented. This paper will be basically a compilation of few facts and few informations, so that most of you might be knowing, to conclude that we coal sector, we are quite safe, and the coal is going to stand for a few decades in our country to feed its sustainable energy sources. I thank the organizing committee to allow me to present this paper. So let us start this paper with a few figures. As you know already, that coal contributes 55% of the energy, primary energy in India. As per energy policy of Niti Aayog, coal is going to be there of 45 to 48% in 2030 and to in 2040. The installed capacity is 229 gigawatt, and another thermal power plant of 47 gigawatt capacity is under construction. This installed capacity projection shows, this is the Niti Aayog's projections, that in 2040, what will be the scenario of different energy matrix? You can see from here that with the increase of various parameters, the only affected area is coal, that is on dark yellow color, as you can see from here. But it is there, it is prominently there. The demand projections as by KPMG, we need to produce more coal in the coming few years. In 2030, the projections is to the tune of around 1.5 billion. Of course, this is the India figure. Coal India and all other different players are to contribute into this. The additional requirement of coal, as on date, last year was poised to 729 million tonnes, and there was the import of 2 tonnes. This import is additional requirement of coal for the country, and if we want to reduce import, we have to produce this coal and more, so that our power plants, our requirements are fulfilled. So in this issue of sustainability of coal, we are going to discuss a few topics. Of course, I will be going quickly through this. Enhancement of production productivity evacuation, ensure quality at doorstep, modernization and technology upgradation, import reduction, diversification and alternate business area. Coal production productivity evacuation is a very common topic, and as you know, with the increase of coal cost of production, to be more efficient, more productive, more equipment friendly, to make our coal cheaper and to be made available to the common consumers. The 2030 statistics, as it can be shown, you know very well that we have the Coal India, we have already promised to our Honorable Minister to produce 1 billion tonnes coal by 23-24. Depending upon the demand and the requirement forecast, the Coal India, along with all subsidiaries, are poised to produce and attain this target, as our Honorable Minister has already been promised. So the figure of 1 billion ton is the figure we have considered for coal CIL. Singareni Coal's Company Limited, they have the production target of around 68. And as you know, that coal ministry has opened up the coal mining sector nowadays, and number of coal blocks are being auctioned for both captive as well as commercial users. As on today, its monopolistic behavior is going to change in very near future, because once the Coal India is going to produce 1 billion, whereas the other private players are going to produce half a billion. So we have to be more competitive, and to be with them in the market, we have to show our efficiency. There are efforts to increase coal production, and most of them are very known facts, that enhance target for exploration, thrust on commissioning of projects, modernization of mines, thrust on infrastructure for coal evacuation. Government has planned a huge amount of money, that means 2 lakh crores for coal and lignite by 23-24, and allocation of coal blocks for commercial usage. There is a typical figure, that is a typical diagram you can see from here. In India, we have the GSI has estimated reserves and the area, coal bearing area. Out of the total basinal area where found is 52,873 square kilometer. From that, around 35,000 square kilometer area where coal has been detected. And out of that area, 19,400 square kilometer area where coal is detected within a depth of 900 meter. So our main focus is to explore this area, 19,400 square kilometer, where we can know our status of coal and we can mine coal from there. CMPD has already taken up this job, and they have done a very wonderful job in this regard. Almost 54% of this area covers within the 900 meter depth has been detailed explored. 83% of area has been regionally explored, and most of the area which are left are being tackled as on date by our drilling subsidiaries. The basic intention is to explore this coal at the earliest, and accordingly government has tried to introduce various other players, including the exploration agencies, to come up and to explore faster. A concept of PL cum ML, prospecting license cum mining license, has already been already been introduced. So the block owner who are going to take this block of regionally explored blocks, they are going to explore and come up with the report for mining. The different coal mining projects existing, we have 450, and out of that there are opencast, underground and mixed types. As you can see, new projects of 58 numbers are going to come up, which are more than 3 million tonnes. And out of the 58 blocks, 46 out of them are on schedule. Rest and it is being efforts are being on to commission it on time. Coal mining projects are being planned through MDO mode. It is an ambitious plan by the coal companies like Coal India and others to deploy mine developer and operator to mine those areas where Coal India can allow them to mine, and they will mine for us and produce coal. There are so many other projects. There are total 58 projects to come up, and in NCL we have one project, Simeria project, has been earmarked for that purpose. Infrastructure for coal evacuations, it is a very well-known and well discussed topic nowadays. 35 projects of Coal India which are producing more than 4 million tonnes per annum are being in safety. Environment and management safety, environment being one of the key parameters nowadays for coal mining. So that comes into picture in a big way. Nowadays, use of spray guns, the fixed sprinklers, the drill machine attached to cyclone separators. This the all equipments are coming out, and we are rather using those machines. This is one of the key parameters of import reduction. As you can see from this table, just I want to point it out that some of the parameters, say coking coal we are importing to the tune of around 50 million tons every year. In Indian context, our coking coal characteristics are not very congenial for our blast furnaces. So we need to import coal. But for non-coking coal, which is to the tune of around 200 million tons, we have to think how to reduce this import. And accordingly, there are different actions are being taken by the ministry, by Coal India, and by our NCL also to save government exchequer from in this regard. The diversification and alternate business area. Now, once you have produced coal, and if this coal is not being used by the consumers and you have to stock this coal, there is a burning problem that coal cannot be stocked for longer period due to spontaneity. So we have to find out a way how to use this coal, how to diversify the use of coal in different zones. And in this regard, a lot of research, lot of actions are being taken by ministry as well as Coal India and different other companies, NLCIL with respect to lignite. And an ambitious plan has been taken by Coal India to gasify 100 million tons by 2030. Coal bed methane to tap the gas which is captured, which has been trapped in the coal seams wherever possible for its economical use. So is the case with coal to liquid, because now the import cost of various such chemicals like methanol, ammonium nitrates, ethanol, and other paraffins which can be produced from coal by its fractional distillations can be whether we can produce coal to liquid, coal to gas to an economic level. And accordingly, there are a number of activities, number of actions are being taken. For example, coal to methanol, Dankuni coal complex already, it has been taken already, tender has been floated. Methanol, ammonia, ammonium nitrate, in CCL it has been proposed. Coal mine methane, in tapping of coal mine methane in Eastern Coalfield Limited, the tender has been floated. CMM and CBM in BCCL tender has been floated, is under evaluation. Methane pre-drainage system, Munidi BCCL, already tender has been floated and it is also under evaluation. Underground coal gasification is a key area. Of course, this underground coal gasification, UCG, is not a very proven technology, and it is accompanied by a number of hazards. But because those coal which are at depth, at isolated patches and cannot be mined economically, whether we can tap energy from that coal, the first attempt is going to be taken up by the country in two areas, particularly in coal. One Kasta coal block is there in Eastern Coalfield where we are going to propose this. And similarly, in case of lignite, two lignite block has been proposed to go forward with underground gasification. The most use of our land area, because our coal companies have a huge bank of land in terms of overburden dumps or in terms of their coal usage areas, whether we can use those areas to generate solar powers. And accordingly, the company has taken up an ambitious plan, and all subsidiaries along with NCL is also a part of that. And as you can see from this chart, NCL is going to set up a 50 megawatt solar power plant shortly. They are going for the rooftop power plant, rooftop powers, solar powers also. And so is this year's plans. Accordingly, the next year there will be some more areas to come up. Now, ministry is thinking something else also, whether to find out some new business areas.
Sir.
Whether to we can go, just a minute, sir. Whether to go for non-coal mining of non-coal minor or minerals, minor or major minerals like sand manufacturing from OB, solar wafer manufacturing, aluminum projects with mining and smelting as a joint venture with Inalco, whether to have directly come into in a mega way with the solar power generation, to install thermal power plants and use the remotely located coal mine areas for generation and use of fuel. So these are the key areas which is under deep discussion and thinking, and we are shortly we are going to find some some of these areas to come up in the platter. In the concluding remarks, we are going to mine coal. Coal is going to be there for coming few decades, but we have to be more cautious, more consumer oriented, more quality oriented, more efficient to make the coal mining cheaper and acceptable to the country, both in the domestic as well as, if possible, in the exporting countries. Thank you. Thank you very much for your kind patience hearing. Thank you.
Thank you, sir, for an excellent presentation. We'll have the question session later because time is running out. Now I request Mr. Manish Kumar to take over and present his paper.
Thank you, sir. Respected Chair, Co-Chair, eminent presence on the dais and off the dais, my greetings to all. First, I express my gratitude to my SMD, sir, on whose behalf I am presenting this paper. I would start with the term overburden dump accommodation, which is the main focus of this paper. It indicates an important aspect of the mine planning, which requires consideration. Say that overburden is not included in the mine planning, but it requires a special consideration while planning the mine of higher stripping ratio. This is because the seams which were left unworkable are being extracted now profitably on account of cost-effective technology. Hence, the subject paper has been conceptualized for assessing the feasibility of mining block ahead of detailed mine planning. So these are some facts. 93.8% coal production comes from the open-cast mines. And as my previous speakers have said, that coal demand is there to sustain for next 20 to 25 years. Burgeoning coal demand has resulted in corresponding increase of size and depth, we all know. But the environmental constraints have now posed a severe challenge on account of very limited space for being provided for mining industry. So these are the issues of concern. Deeper deposits necessitate handling of large overburden dumps, and accommodation of huge dumps within limited space within the provided mine precincts is very difficult nowadays. Basically are very restrictive in providing space for external dumps. So whatever we produce, whatever waste we produce are required to be accommodated within internally within the mine precincts. And even there are restrictions on dump decks, and dump parameters aggravate this issue further. So there is another fact. According to the Coal Directorate of India, MCL has reported a minimum stripping ratio of 0.97, whereas NEC has reported the highest stripping ratio of 10.0. 9. So to summarize, the problem statements include effect of overburden OBDM accommodation. It is high stripping ratio, environmental constraints, minimum lead, because most of the projects we go for outsourcing, they go for minimum lead, maximum internal dump, maximum to be accommodated, minimum space for external dump, and of course the regulatory affairs. So what we now intend to do in this paper is to determine an optimum size of mining blocks with respect to the parameters. I'd go briefly on the paucity of the time, so I'd go briefly on the derivation part of the formula. Just to deliberate the concept of this, this can be surface profile of mining block area. Basically in this paper I've tried to conceptualize a terrain area into an equivalent cuboid like this. You can see the two seams in the block, cuboid block. A part of overburden is adjusted in the external dump, which is calculated in an isolated manner, and this is the section. This is the whole process is basically calculation of sectional area. It is converted into volume to assess its feasibility of space. So it may not be important to go into the details of derivation of the formula, but I would suggest the end of this, whatever is derived. So, whatever formula is derived in this volume, you can say, there is Sn is equivalent to what the parameters are given over there, that is there in the paper. What I want to say that ultimately I have adjusted this formula, rather customized this formula in two models. One model is the central entry and the two peripheral entry to the bottommost seam floor. This is very important because if we go on increasing the number of entries in a mining block area, we will reduce the feasibility of dump accommodation, or otherwise you can say we have to increase the strike length of the mine. So if you go for one single entry, you will have this shape of overburden dumps while the mining is. And if we go over the double entry system, triple entry system, we will have this shape of overburden dumps while in the process. So in case of model 1, we derive this formula for strike length as you see on the board. And in the second case, model 2, we have this formula. So now whatever formula we have derived, what I have tried is to substitute the parameters of one of the OPENCAST mines, Jayant OCP of NCL, in this formula to check, to verify whether my formula is working or not. And the result was quite encouraging. You can see that as per the formula, the result came out to be 3.518 kilometer, and actual strike length is also near to the derived result. So I go for the result analysis of the parameters, whatever. These are the sum of the parameters. We basically remain constant for the seam in the area, like specific gravity of the coal, average deck height. These comes under environmental stipulations. Deck width, angle of repose, swell factor of the overburden, similar to the area. And these are the parameters you can see in the decks in the overburden. These can be varied to optimize the size of the mining block. Total width of the haul roads based on the number of entries. In this, what I mean to say is, if we go for one entry, we can reduce. We can say that the haul road total width of the haul road is just 40 to 60 meters. And if we go on the increasing the number of entries, it will the width will go on increasing. Depth of the mine as per the block area, average stripping ratio as per the block area. And those are the results for model 1 and model 2. And this is basically a model for this chart basically serves the purpose of optimizing the mining block area for a particular reserve. So this, some variations have been shown over here. You can see that variation of the strike length of the mining block with respect to the varied stripping ratio for a given average depth is quite proportional. This has been, this result has been evaluated from the table. Similarly, for a given stripping ratio, if you take the stripping ratio as 3, the variation of the strike length of the mining block area with respect to the average weighted depth of the mine block area, it goes like this. It is quite parabolic. I mean, say exponentially, it's not directly proportional. This graph, what you see on the board, is basically a step. Yeah, it's a process to optimize the block area. What I have done in this, that I have varied all the 3 parameters: the stripping ratio, the average working depth of the mining block, and also the number of decks in the overburden dump. The moment the parameters were going on, the moment the graph was going on increasing, the strike length was going beyond 5 kilometer, I increased the number of deck in the overburden dump, and then I got the result like this. Similarly, when after few increase of the depth and stripping ratio, the moment the strike length increased beyond 5 kilometer, I increased the number of decks. This is our try to optimize the strike length. In fact, you can say, in other words, you can say the size of the mining block for planning of the deposit. So what we find that can be considered for dump planning are stripping ratio, average depth of working, number of dump decks, and mine entries. Stripping ratio and depth of working is specific to the block. We can go and method of working planned in such a way that mine entries can be kept as minimum. What we conclude? Average weighted depth of the mine for a given ratio is an important parameter for determining the optimum strike length. We have seen in the chart table, also in the variation of the graph. For a given depth of the mine, strike length of the mining block area is proportional to the stripping ratio. I have said earlier, increasing the number of entries basically affect the dump accommodation issues. I have tried to show you that the strike length of mine area can also be optimized by regulating number of decks and deck height in the overburden dumps. The model derived for determination of strike length for a given stripping ratio appears to be in conformity with the actual scenario, as I have shown you in case of Giant OCP. So this is the takeaway. The model can successfully address the burning issue of overburden dump accommodation, provisions of extant stimulation regarding safety and environment. The model can be used as an effective tool to find a solution for determining required parameters of given size of mining block. Determining mining block area as per the for existing mines. As per the model, I can suggest that amalgamation of adjacent mine can be helpful in solving the issue of dump accommodation. Thank you, sir.
Thank you, Manish, for an excellent paper. So, any questions from the 3 presentations that we had this day? Somebody should be there.
Thank you to both the speakers. My question is related to Mr. Manish Kumar. You have done excellent work and accommodation of the dumps inside the mine, and you have mathematically certain calculations. But have you done the, at what factor of safety you are giving the 10 decks, number 1? Number 2, with the strike length, how many entries should be with the increase in the strike length of the deposit, what should be the number of entries?
That's what I have said, that this model is basically This method can serve the purpose of pre-feasibility study for actual detailed planning of a mine. First thing, so far as safety is concerned, all these formulas have been derived while keeping, basically the variables are kept as the same in the formula, but the model which I showed in the chart has considered the minimum safety standard, minimum parameters that DGMS or other safety organization stipulations have been provided with.
What is that value?
40 meter of width is taken for the haul road, deck 30 meter gap between the decks horizontally and also vertically.
So that gives how much FOS?
I could not get you, sir.
What is the factor of safety for that accommodation, for the dump slope?
The stipulation says basically it is different for different mine parameters, different mines.
For your case, I am asking for you.
In case it is 30 meter deck is provided for MOF. In case of NCL mines, they have said up to 150 meters in external dump area. Otherwise, a deck of 30 meters each, up to 7.
Okay, and the number of entries?
Number of entries depend upon what method of working you are going to adopt. If it is a dragline mine, you have to think in that way. If it is soil dumper combination, you have to think in that way. But if we have a problem of overburden dump accommodation, so we should, what I suggest is that we should go for minimum of entries.
Yeah, minimum is 1. That is why.
Obviously, minimum is 1.
Minimum is 1.
Yeah,
But
obviously, minimum is 1.
we should have 2 entries. That is my
No,
perception.
sir. No, sir. I couldn't. Basically, I differ from you. That will depend upon the planning, detailed planning of the mine.
Okay, thank you.
And my entry system, from entry system, what I mean is that entry to the bottommost seam, not to the mine. Because to the bottom, approach to the bottommost seam basically determines the volume of the dump. Thank you, sir.
Thank you, sir. Thank you. Sir, with due permission of the chair, just one submission, sir. For a dragline mine, we should have the length of the cut, what we call. That the dragline which has been deployed should cover the length, should be transferable or should complete its cut for once in a year or for a period more than a year. It should not be completing the cut more than once in a year. That is one, just I wanted to add. Thank you, sir. Session chair, sir.
So, any more questions?
Manish, first of all, Manish, I'm a jazz GMS Commission CCL. Manish, thanks for presenting such an excellent presentation. Manish, while going through your PPT presentations, I have a doubt, is it implemented? Just starving for even an inch of land. So how it could be possible, this model, accommodation of the overburden in case of CCL, ECL and BCCL, please.
First of all, this paper was basically focused on the issue of overburden dump accommodation, and this is more applicable in the area where stripping ratio is higher, you can say more than 3 in that area. In case of CCL, BCL mines, first we have to verify whether the stripping ratio is more than that. Otherwise, if you get more coal and thicker seams, you will not have the issue of overburden dump accommodation. This is only where issue the stripping ratio high and you don't get much space for OB dump accommodation.
So what do you mean to say that this is not applicable in case of the mines
No,
which is
it is applicable. It is applicable, but
yeah.
in most cases, unless and until dragline mining, what I see in CCL and BCCL cases, you can approach the mine bottommost seam with a single entry, and that is the minimum area which you use for approach purposes, and that could already help
Acha,
in overburden dump accommodation.
Hello.
Okay,
Manish.
thank you very much.
So now that it's almost 2:30 now, anybody seeking clarification could individually meet or they could interact through mail. We shall have to get a breather now. So I must thank all the speakers, Professor Ilmaj, Shri Bhavan Singh, Director Technical Mahanadi, Dr. Anindya Sinha, Director and PM Prasad Saab, CMD CCL on his behalf, Shri Manish presented the paper. I thank all of you for very quality papers. I really appreciate the level of input that has gone into them. And I hope we get the same quality in succeeding sessions also. So I hand over to Sri Satish Jha for carrying out the balance work.
Thank you, sir. In our keynote session of ICOMS 2020, we had 4 technical papers, including 2 physical presentations, 1 virtual presentation from Turkey, and 1 from Mahanadi Coalfields Limited. The session was full of enthusiasm and valuable knowledge. As an extract from our keynote session, it can be stated that coal is the backbone of world's energy generation. 40% of world's power and 69% of India's power generation is coal-based. Wind does not always blow and the sun does not always shine. Hence, there is a question mark about reliability of renewable energy. Our demand is continuously increasing. In all the presentations, we saw that we'll have to move towards eco-friendly coal mining and we'll have to re-engineer our operations like overburden dump management to increase the productivity of mines. We also saw a futuristic approach of coal in India in our keynote speech of our director, sir. It is our pleasure to have you all, sirs, as keynote speakers. Now I request Chairman of this session, Shri S.S. Sinha, sir, to kindly felicitate our keynote speaker, Shri Anindya Sinha, sir, DT Operations, with a memento. Please, sir. A big round of applause for DT Operations, sir, as a keynote speaker. I also request our chairman and co-chairman of this session to kindly felicitate Speaker Shri Manish Kumar, sir, from CCL with a memento. I am very much thankful to Shri S.S. Sinha, sir, DTPNP NCL, for chairing the keynote session and helping ICOMS with deriving out number of recommendations. I request Shri A. Pathak, sir, to kindly felicitate DTPNP, sir, with a memento. Shri Atmeshwar Pathak, sir, please felicitate DTPNP, sir, with a memento. A big round of applause for the chairman of the session for chairing this session and deriving out a number of recommendations. Now I request Sri Rajiv Kumar, sir, Area General Manager Amlori, to kindly felicitate co-chairman of the session, Shri N.B. Singh, sir. A big round of applause for our keynote speakers and chairman and co-chairman of this session. Now I conclude the keynote session here. Have a lunch break, and it's my request to all the delegates, guests and participants to gather again in Hall A for upcoming wonderful session on production, productivity and safety in coal mines after half an hour.